We have question 6 out of 10, and this one there's no calculator. It's out of 4 marks and it comes in 2 sections. It's quite a long winded question, but take a look at it and attempt it. So you can pause the video now and have a go at it if you wish. But let's go through this. So a quadratic parabola has an equation of the form y equals ax squared plus bx minus 3. And we know that the values of a and b are known. The discriminant is positive. So the discriminant is b squared minus 4ac. And the line of symmetry is in the form x equals a positive integer. So we have to sketch any possible parabola, and we don't have to find the values of a and b explicitly, but we do have to mark the points of intersection with the x and y axes. Let's have a go at this. So you have to read the question carefully. We have to find points of intersection with the coordinate axes. Let's first of all have a look at the y-intercept, the point at which it crosses the y-axis. Now there can only be one of these on a parabola. On a quadratic parabola, you can't have two y-intercepts. So to find the y-intercept, we can have a look at the equation. Of ax squared plus bx minus 3. Oops. But for the y-intercept, x must be equal to 0. So if you put 0 in, this becomes 0. We get that is 0, the bx is 0, and it just becomes minus 3. So it would be 0 minus 3 as the y-intercept. And want to mark this on, and that's minus 3. The discriminant is positive. Now you know if the discriminant is greater than 0, then there must be two real and distinct roots. So the roots are the points at which it's going to cut the x-axis. So you need two distinct points at which it will cross. And the line of symmetry is x equals t. We have to select a specific value, but you can go with anything as long as it fits the conditions and it makes mathematical sense. Let's go with, I don't know, t equals 2. So suppose x equals 2 is the line of symmetry. We don't have to include the line of symmetry, but let's suppose x equals 2 is the line of symmetry. So that means that the turning point, the x value of the turning point has to be on the line of symmetry. Suppose we have the turning point has to be then on x equals 2. So we could either have a minimum or a maximum turning point. So one way you could do this one is you could have, suppose, 1 and 3, and have the maximum turning point at x equals 2. And you do have to be careful on this one, because the two roots have to be equal distance away from the turning point. So you could do 0.5 and 3.5. You could do 1.5 and 2.5. But the idea is that the x value of the turning point has to be between the two roots because of the symmetry. And let's then sketch the parabola. And it goes through like that. Alternatively, you could do this another way. I'll do this on another page. But let's check the conditions are met. So the discriminant is positive. Two roots. The line of symmetry is x equals 2. And the intercept is correct. I should put the origin, y, and x. Okay. We don't have to find the y-intercept of the turning point. We just have to find the x value. We don't need the y value. But we could do this a bit differently. We have the turning point. We could make t 1, 2, 3, 4, make it anything as long as it's a positive integer. But we'll stick with 2 again. And this time let's do a minimum turning point instead of a maximum turning point. And for this one, we need it so the two roots are equal distance away from 2. So suppose that is the minimum turning point. Well, we could have -2 and we could have 6. Up. And we have the minimum turning point there. And we've indicated all of the information that we need. So again, this would satisfy those conditions. But let's have a look at how the marks would have been imposed. The first mark I would give is for interpreting the y-intercept and getting the correct y-intercept. The second mark would be for the two roots. And the third mark is for getting the shape and for getting the turning point in the correct place. And that's section A we've done. Section B, it looks easy, but it's difficult. Another parabola has an equation of the form y equals dx squared plus ex plus f, where d, e, and f are unknown. State the value of f such that e squared minus 4df is 0 and the line of symmetry is x equals 0. Okay. I'm going to go one forward and I'm going to then wipe this one off. So e squared minus 4df is the discriminant. And if it's equal to 0, then we have two real and equal roots. So it will only intersect the x-axis at one point. It has to do that at just one point. The line of symmetry is x equals 0, so the turning point has to be on the line x equals 0. So we have to get the turning point such that x is 0. So this. So all of these satisfy the second condition. The sketches are not too good, but the point is you see that the line of symmetry is x equals 0 because the turning point has x equals 0. Of course they're not symmetrical, but the idea is these each would satisfy the second condition. If I spent a bit more time sketching them out perfectly, but we need it so the discriminant is 0 and it only touches at one point. So it would have to be such that the minimum turning point is along here. Or you could do this with the maximum turning, with a parabola with a maximum turning point. So again, I'm going to do this one in blue. You could have that and this. So both of them satisfy the condition of this being the line of symmetry and it cuts the x-axis at one point. So 0, 0 would be the turning point in either case. If you plug 0 in terms of x and 0 for y in this equation, we have dx squared plus ex plus f. We put 0 in here, that becomes 0, that is 0, so f must be 0, and that is 1 mark if you write down f equals 0. So I hope you found this video useful. Leave a comment if you have any issues, but thanks for watching and best of luck with the studying.